Jai Shri Gurudev. In this session, we will see the degradation of Heme. The competency addressed is BC 5.8. These are the specific learning objectives of this session. First one, to discuss the formation and fate of bilirubin, to know the reference ranges of total, direct and indirect bilirubin, principle of van den Berg's reaction and how to interpret the results of van den Berg's test. Now let us learn about catabolism of heme. The lifespan of RBC is 120 days. Every day more than 200 million erythrocytes are destroyed in RE cells of liver, spleen and bone marrow, which releases an approximately 6 grams of hemoglobin, from which nearly 250 to 350 milligrams of bilirubin is formed. This formation requires a very important system, that is heme oxygenase system. So once hemoglobin is released in the RE cells, so it binds to haptoglobin so that there is no loss through urine. The globin part, that is the protein part of hemoglobin, is released and it adds to amino acid pool. The remaining non-protein part, that is heme, again it binds to hemopexin so that it is not excreted through urine. Now this heme is acted upon by very important enzyme system, that is heme oxygenase system, which requires NADPH and molecular oxygen for their activity, and this heme oxygenase system converts heme to biliverdin. So a green colored pigment is formed. A little more information about heme oxygenase system. It's a microsomal enzyme and it is substrate inducible, that is heme induces its synthesis. It cleaves alpha methanol bridge, which is between ring 1 and ring 2 of heme. The iron in the form of Fe3 plus is released, which is reutilized, and this is the only reaction which releases carbon monoxide in your body. Now what happens to this biliverdin is it is acted upon by one more important enzyme, that is biliverdin reductase, to convert it to an yellow pigment, that is bilirubin. So biliverdin reductase, it requires again NADPH and molecular oxygen for its action. Biliverdin reductase cleaves the methanol bridge between ring 3 and 4. So this is how hemoglobin is converted to an unconjugated bilirubin in RE cells. Further, we will see what happens to this unconjugated bilirubin formed in RE cells, that is fate of bilirubin. So this bilirubin formed in RE cells is sparingly soluble in water, that is why it's unconjugated bilirubin. And final detoxification process and secretion happens in liver, in the hepatocytes, and it has 3 stages: uptake by liver, conjugation with the glucuronic acid, and secretion into the bile. So the bilirubin formed in RE cells is sparingly water soluble, that is unconjugated bilirubin. So it has to transport to the liver. As it is water insoluble, it binds to albumin for its transport. Albumin has 2 binding sites, a high and low affinity sites. The high affinity sites can bind 25 milligrams of bilirubin per deciliter, and this high affinity site bound bilirubin can be displaced by few drugs like penicillin. So it should be very cautiously used during neonatal period. So this unconjugated bilirubin is when once it reaches the hepatocytes, only bilirubin is taken into the cells through facilitated transporter system. Inside the hepatocytes, bilirubin binds to ligadin or protein Y. So during transport, it binds to albumin, and in the cytosol of hepatocytes, it binds to ligandin and protein Y. This unconjugated bilirubin undergoes two steps of conjugation catalyzed by the same enzyme, that is UDP glucuronide transferase. And UDP glucuronate is a conjugating agent here. So first it forms bilirubin monoglucuronide, and after second conjugation process by the same enzyme UDP glucuronide transferase, it becomes bilirubin diglucuronide. So bilirubin diglucuronide is a conjugated form of bilirubin. This UDP glucuronide transferase is located in ER portion. So the conjugated bilirubin formed in the hepatocytes is secreted into the bile through an active process. So here you have to remember the uptake is facilitated transport mechanism, but secretion is an active, and this is a rate limiting step. So the bilirubin, that is conjugated bilirubin, which is secreted into the bile, is stored in gallbladder. Whenever its requirement is there, it is secreted or it is poured into intestine. So after its function, this conjugated bilirubin is acted upon by beta glucuronidase, which deconjugates and reduces it to form urobilinogen. So this urobilinogen major part is converted to urobilins or stercobilins. A small portion of it enters enterohepatic circulation. Nearly 8 times enterohepatic circulation happens once it is secreted. And during this process of enterohepatic circulation, a small portion of it is seen in or excreted in urine. Major portion of urobilinogen and stercobilinogen is excreted via feces. That's why these are the ones which give color to the feces and urine. So that's about the formation and fate of bilirubin. Now we will see the reference ranges for these conjugated and unconjugated type of bilirubin. Conjugated is called as direct bilirubin, unconjugated is called as indirect bilirubin. This is based on the van den Bosch reaction. The reference range for total bilirubin ranges from 0.2 to 1 milligram per deciliter. Conjugated is 0 to zero point 0.4 milligram per deciliter. Unconjugated is 0.2 to zero point 0.8 milligram per deciliter. So normally we will have little higher unconjugated bilirubin when compared to conjugated bilirubin. In further slides, we will see what is this direct and indirect based on van den Bosch's reaction, the principle and interpretation of the reaction. Van den Bosch's test. The principle is bilirubin reacts with diazotized sulfonilic acid to produce purplish pink colored compound called as azobilirubin. So this reaction can be a direct positive, that means the color formed is immediate. So conjugated bilirubin, as it is water soluble, gives immediate color with diazotized sulfonilic acid. Hence it is called as a direct positive reaction, and the bilirubin is called as direct bilirubin. Whenever there is unconjugated bilirubin, which is water insoluble or sparingly soluble, it gives color with the diazotized sulfonilic acid only after adding a solubilizer like methanol. Hence it is called as indirect positive reaction, and the unconjugated bilirubin is called as indirect bilirubin. Whenever there is both conjugated and unconjugated bilirubin, so color appears immediately with the diazotized sulfonilic acid, which intensifies on adding methanol. So this signifies that there is presence of both conjugated and unconjugated. So this type of reaction is called as biphasic. So this direct, indirect and biphasic also tells about what type of bilirubin is elevated in the serum and also the pathology behind it. For example, if it is direct positive, then it goes in favor of obstructive jaundice. If it is indirect, goes in favor of hemolytic. If it is biphasic reaction, it signifies there is both elevated conjugated and unconjugated, which is commonly seen in hepatic type of jaundice. So with this, we have discussed the formation and fate of bilirubin, the reference ranges, the principle and interpretation of Van den Berg's test. Thank you.